a strong capacitive coupling that then moves the ionosphere, and where CO2 is involved. This is my kitty here who's interrupting our show. It has been observed and seen by experiment. Again, I think the big notion here is whether or not the observed phenomenon is causing the intensification, or whether the intensification is a product of, or the capacitive coupling is a product of the intensification. Well, I think there's a lot of evidence, again, not looking directly at the storm itself, but outside the storm, that indicates that, certainly correlates, that the intensification is occurring electrically vis-a-vis the organization that occurs by the ionosphere being moved and organizing the upper atmosphere and reducing shear and allowing the storm to have this upper high and surface low, and not being decapitated, allowing the storm to breathe. Some of that evidence is, and by the way, the capacitive couplings have been observed by a Stanford paper which looked at the acoustics of a storm by having two stations between Boston and Bermuda, and Isabel went between these two stations, and the signal generated changed as a result of the capacitive coupling that existed there. And so again, these couplings, these static fields have been observed. Now, if we make the assumption that electrically storms, that there's this complexity that electrically storms rapidly intensify with proper electric conditions, not only is CO2 implicated, but we can make some forecasts, and this gives us some forecast skill. For instance, El Nino. I'm more interested, I mean, certainly the warmer the ocean temperatures are, the more conductive they are. That's a correlation, and that's a mechanism. But El Nino is also a product of they call it El Nino Southern Oscillation, and the Southern Oscillation, or the SOI index, out of Longpodic, is very interesting because it's two measuring stations of pressure between Tahiti and Darwin. So if you have low pressure over, say, Tahiti, that means that there's going to be clouds there, and clouds have an ability to organize and carry electrical charges. And so this kitty here, electrical charges from a coupling, when they discharge, it's just like a capacitor discharging, and it allows a lot of electrical energy to move from one place to another. And so when you have a specific kind of index, in this case a rising positive index, it's an indication of charge movements globally. And so what by observation what's been seen is that when you do have this rising SOI index, it's an indication globally that charges are moving to an area where, say, a hurricane would form. And in this case, with respect to the East Pacific and the Atlantic Basin, rising SOI index are correlated strongly with the appearance and rapid intensification of a tropical storm. The same thing, and again, I don't want to cite the papers, but the Madame Julian oscillation is another water movement index, and it also can be correlated, or is correlated, with the appearance or the likelihood of a rapidly intensifying tropical storm. Again, SSTs matter. They're not the be-all, end-all, but if you have warm SSTs, the more conductive the oceans are, and the more likely that there's going to be a capacitive coupling. The other interesting thing about this theory is it explains some observations. For instance, tropical storms are less likely to occur offshore, and For instance, you'll see tropical storms form in the East Pacific along the west coast of Mexico, but you're much less likely to see them form in the Central Pacific. Usually they exist and then move out to the Central Pacific, but they're much less likely to form. And that's because the source of a displacement current or charged or potential difference that would move the ionosphere and cause an organization, the further away from those lightning strikes that you are over land. 90% of lightning occurs over land with thunderstorms as a source of this potential difference. The further away you get from the source of lightning, the less likely you're going to have this organizing feature. So presently, the present state of the science is that it just has to do with shear mass, that you get upper atmospheric conditions that are not conducive for a storm, and that's the reason why offshore tropical storms are less likely to form, even though the oceans are warm and there's a big source of latent heat.